Hello and welcome back to this random table where I fix stuff. Today we've got this Macintosh IIcx, which does not power up. I can plug it in here and show you what exactly it does. You plug it in. So right now it's not doing anything. Oh, now it powered up. What didn't power up before? At least the hard drive turned on anyway. Didn't hear the chime though. Okay, let's get a screen and see if this has any output. That's interesting. So I went to plug in a monitor and I bumped the Ethernet cord and this computer completely died. So now when I plug it in, nothing happens, and if I hit the power button, also nothing happens. If I unplug the monitor, try plugging it in then and see if anything happens. So again, nothing. So I'm going to do, just in case there's no difference, so I'm going to open this up and see if I can remove the So I can't remove the Ethernet cord and see if that might be the source of the problem. See, it's got the video card here, and this is the Ethernet card. So let's just see if we can't pull this out. It looks like it shouldn't be too hard to get out, but I'll need two hands to do it. So that's out. Just Ethernet, and this is I think that's 10 base 2 Ethernet, the old coaxial style. Let's just see if we plug it in now, makes any difference. So there's still nothing. I'll try there for a minute. Okay, so there's still nothing happening. It looks like it sounded like it tried to hit it for a minute, but then it just didn't continue. So I think I'm going to see if I can get it the power supply connector. I did find a pinout for this power supply online, and also a diagram of the startup circuit. So the power supply has a standby power that's always supposed to be 5 volts. And then when you press the power button, it's supposed to latch that 5 volts onto a power up signal, which then tells the power supply to supply all the other voltages. So two possibilities here. One is that, well, actually more than two, but one possibility is that the load of there's like an intermittent short somewhere, that the load of the computer is too great for the power supply to keep up with, so it goes into emergency shutdown. Another option could be that the latch is not latching, so that it's not actually telling the power supply to power up. It's just completely dead now. So let me see if I can get at that connector and see if I can figure out, see if the standby voltage is there. Well, I played with it a little bit more, and it looks like we finally blew a capacitor, or something. Doesn't smell like capacitors. So yeah, let me take the power supply out and have a look inside. I think we've finally got a very good direction on where to start. I'll have to excuse the traffic noise. I've got the door open to get the smoke out. But I popped the power supply apart here. You can see our culprit is one of these lovely WIFA capacitors. You can see RIFA right there. And these things love to explode in old electronics. You see that? Oh, it's in the center. So this guy right here, the whole top's just blown right off and black stuff is spewing out the side. Same brand, also blew up in my Osborne computer, it spewed a bunch of smoke out. So I think I'm going to replace all of these WIFA caps. I see at least 4 right here. So what's the value on this one? 0.22. Now these are an X2, this one says X2 on it. So if you can I don't want to move this around too much because there's some pretty thin wires in there that you can't unplug, so I don't want to risk breaking those. But there's at least 4 right here. I see a 4700, 4700, 0.047 x2, and this is a 0.022, or no, just 0.22 x2. I should have all those values, just not x2. So we'll just pop those in for now, and then at a later date I can get the proper x2 capacitors if this fixes it. If it doesn't, we'll have to keep investigating, but definitely a good place to start is right here. And even if this doesn't fix it, I don't want the rest of these blowing up on me while I work on this. So I'll work on replacing these, and then we'll pop this back together and see if there's any difference. Okay, so the capacitors are replaced. Some of the new ones are a little bit wider than the old ones, like this one's just a little bit wider, and the 4700s, 47 picofarads are a little bit wider too, but this shouldn't be a problem because these connections on this side are going right to ground anyway. The trace on the back of the board here comes right up to this rivet, which bolts into this point right here. So even if these touch the side of the case, that's fine. They're connected there anyway through this rivet. So you can see these are the old ones I took out. This one kind of disintegrated when I was trying to pull it out because it was glued in. And then this is of course the one which exploded. You can see the top just blew right off there. So I replaced them all with the right value. These are like 250 volts. I think they're all 250 volts. This one's 250 volts. So is that one. See that one? That one is as well. I don't bump my camera. The ones I put in there are 630, because that's what I had. It should be okay. I mean, if I get this working, I can always come back and replace these with the proper X2 class capacitors. While I was in here, I had a quick look at the electrolytics. I don't see any that look bulging, so hopefully those are all okay. I mean, it's not really a valid test, but if it's bulging, there's a good sign that it's going to go bad, but just because it's not bulging doesn't mean that it's good. Anyway, we'll put this back together and see if that made any difference. I'm not really hopeful that it did because it looks like these are all input filtering. I didn't trace out the circuit that much, but it looks like, especially the one that blew up, looks like it's just input filtering. So I don't think that would affect the power supply as far as powering up, because it's just right across the input, so it wouldn't affect the actual switching circuit, I don't think. But anyway, we'll put this back together and just see what happens. Okay, all back together. Let's plug it in and see what happens this time. First, unplug it. Plug that back in. Just plug the computer in and see what it does. I don't expect it to work, but for nothing. That's consistent with what we had before. And still nothing. So I think before I had it plugged in for a little bit, before it started working. So I'm just going to see what happens if I do that again. It's kind of interesting behavior. It's all the way plugged in. There's a power button. Power button doesn't do anything at all. So let me just let it sit there for a minute and then we'll try it again and see if it makes any difference. Okay, so it just turned on. I was playing with it a little bit and it just turned on. So let's try plugging the monitor in. Turn the monitor on. So turning the monitor on. I just have it plugged into the switched outlet. That's really square outlet here. We'll see if we have any video output here. I can plug it in, that is. Plug it in the right way. I'm not quite sure what settings I have to have on this thing in order to get it to work. Monitor's not detecting anything, but so in order to get this to work with the VGA monitor, you have to set the little settings on the adapter here to whatever your monitor has. But for one thing, the instructions are for multiple different adapters, and this adapter doesn't have a model number on it, so I'm not sure which settings I'm supposed to go by. And I'm also not sure. I'm going to show you all the different list of settings here. So this is for one model, this is for a different model, different model, different model. Like I said, I'm not sure which model I have, because there's no identifier on the thing itself. So I'm not sure if this is in all the way. Looks like it could be. Let me. I think this thing isn't quite going in all the way. Let me play with this a little bit and just see what I can come up with. So I wasn't able to get anything to come up on the monitor, but I decided that rather than chase that down, I would rather chase down this power supply problem first. So I took out the hard drive and floppy drive because there's a battery under there, so I took the battery out. That didn't seem to make any difference. I took the RAM out also. There's only one RAM stick in there, and that didn't seem to make any difference either. Of course, that would be for the power up, not for the power supply, but anyway. So what I'm going to do is I've identified two traces down here, which would be these two right there. If you can see what I can't see what I'm pointing at. It'd be these two right here, this one and this one. There's two horizontal ones. You can see that right next to right in front of this SCSI connector here. This one and that one. One of those is the 5-volt standby, and the other one looks like it's the power up. So what I'm going to do is, I looked at the schematic, and it looks like there's a 220 ohm resistance that holds up the power on signal, I think. So I'm not sure if it holds it up or it pulls it, or that's what it uses to pull it down when it wants to shut off. But anyway, just for safety's sake, I got a 220 ohm resistor in parallel with these two leads, which also go into my multimeter. What I wanted to do was just clip the alligator clip, have one inside the socket on the meter, and that way I could use both the meter probe as a probe down there. But of course, the way they designed this, you can't fit an alligator clip in there, so my only choice is to use my ice pick as one of the probes. Whatever. So let's plug this in, and we'll try jumping those two together and watch the current on here, and just see if it'll power up with those two jumped together. I noticed that sometimes if you hold the power button in, it'll stay on. So I definitely think there's something up with the latching circuit there. We'll just try jumping this out and just see what, if anything, that does. Of course, be sure to watch the current. Wish this clip would stay on here better. Try to get around the camera here. So this is the 5 volts here. Show them on the right thing, and this is the. Okay, so absolutely nothing there. Oh, there it goes. So it just turned on. We're drawing 0.51 milliamps, 0.48. So let's see what happens if I release. Okay, so it's staying on now. We still don't have any chime though. So I think there's something else that might be wrong with this. I did notice that it has these little capacitors here that sometimes like to leak. It doesn't look like these ones have leaked though, so I'm not sure if that's the issue. But I do see something on top of these chips, and it looks like, if you look at these chips right here, see, they look like there's something on top of them. Looks somewhat corrosive. So it looks like something might have dripped in there. That'll be right underneath the floppy drive. Let's see what the bottom of the floppy drive looks like. So the bottom of the floppy drive, she looks pretty clean from what I can tell. I don't see any signs of any liquid on that. Except for maybe that chip right there looks a little bit wet. But it doesn't look like it dripped though. Not quite sure what that's about. But it definitely looks like something dripped on those chips, because you can kind of see some of the pins are a little green looking. So let me try and clean that. I'm not sure if that would be related to our problem or not, or what that even is. So anyway, it looks like if you jumper those two out, it will start up. So let's see if it'll turn off with the power button. So the power button turns it off. Let's see if the power button will turn it back on again. No. So the power button is completely dead now, not turning it on at all. Even if I hold it in, it's not. So let's try jumping this out again and see if that'll turn it on. So maybe the issue is in that circuit. I'm thinking that there is an issue in that circuit. So let's try jumping these out one more time here. Yeah. Yeah, I think there's definitely an issue in that circuit. So if I jump those two out, it'll turn on, but the power switch doesn't always turn it on. So let me see if I can identify the components in that circuit. I'm not sure where they live on the board. And see if I can figure out what's going on with that. But we solved the issue of it doesn't seem to want to actually boot. Like there's no chime and I couldn't get anything on the monitor. I'm not sure if that's because I don't have the right settings set up in that stupid adapter, or whether the video board is just not putting out any signal. Anyway, let me see if I can identify the power supply latching components. Yeah, so the power button turns it off, but won't turn it back on again. Okay, I think I might be making some progress here. Let's pull you back so you can see the front. I've got it plugged in. If I push the power button, see it turns on right away. You see the green light there, and it stays on. Push the power button again, it'll turn off. And you push it one more time, turns on, stays on, and turns off. So the first thing that I did was, if you look down in there, those chips, I cleaned those up, and then the pins looked pretty bad, so I just went over and resoldered those. The pins on these two chips, this one and this one. Those are two 74HC132s that are involved in the startup latch. I'll show you the schematic in a minute. So I cleaned up the pins on those, and that didn't make any difference. So then I started checking some voltages, and one of the pins I checked, I think it was the second to last one down here, was like 3.8 volts or something, which didn't make any sense to me. I mean, these are logic chips. You shouldn't get intermediate voltages like that on them. So I looked at the schematic and I noticed that one of these capacitors was also connected to that pin. So I popped the capacitor off and the voltage went up to like 4.8 volts or something like that. So I just went ahead and replaced all four of these capacitors. These are the old kind that like to leak. Focus. These old fish-smelling ones. Same thing that went bad in the video Walkman. So after replacing those, we seem to have restored the normal power on functionality as far as the power supply. We're still not getting any chime though. I did notice that there's one more there and then three more back there, so while I've got my capacitors out, I'm just going to go ahead and replace those. I mean, whether they're bad or not, they'll probably go bad eventually, so it's just probably a good idea to replace them now. So I'll go ahead and do that and see if that makes any difference. You can see I've got the RAM out just to see if that would let it, to see what, I'm not sure what's preventing the chime, so I took the RAM out, just have one stick in there, but that didn't make any difference as far as it not chiming. So replace those capacitors, then we can move on to see why it's not chiming. The chime is basically its BIOS check. I'm not quite sure what exactly it checks in that check, but whatever it is, it's failing, so we'll move on to that next. Okay, so I've replaced those capacitors, the 447s and then two 10 microfarads, and then the 147 there and the three in the back. So we'll just give this one more test to make sure it still turns on, and then we'll start putting a few things back in. We can put the floppy drive carrier back in. Like I said, I'm not sure why it's not chiming, but I think I'm going to start by playing off the memory first. But I just want to get some of the stuff put back together a little bit first before I start doing that. So anyway, we'll plug this in. Make sure that when we push the power button. Well, that was unexpected. It's not the chime I was expecting. It certainly plays some sort of music. Okay then. Let's put the video card back in. Actually, we'll start with the floppy drive, then the video card, and then I guess we'll see if it gives a picture now that it, I guess, chimes. Turn it off. So this is actually very nicely modular. The power supply out here. So you can see on the bottom of the power supply, the plug is directly on it, and then that just plugs into the plug on the motherboard there. You see that chip right next to the plug is our CPU, MC68030. I think that was just the second to last of this line that Apple used. They went into the 68040, and then they switched over to PowerPC. Anyway, so this whole plastic carrier is a carrier for the hard drive and the floppy drive. Usually the floppy drive is on the bottom there. And this just slides in here. You can see there's a hook here and then a catch here. Well, that hook goes, good framing. That hook goes in here and then the catch goes against here. So should be able to just kind of slide this in like that, and it snaps in. And then there's one screw that goes down in there, and I might actually have to look for that a little bit because I've made quite a mess here replacing these capacitors. Yeah. So give me a minute to find that screw and then we can proceed. Okay, found the screw. It's just a really long Phillips screw, so we'll drop that down in there and then tighten it up with a screwdriver. It actually kind of reminds me of a PS2 with the minimal screws and ease of disassembly and reassembly. Let's put the screwdriver in the right mode. PS2 models 50 and 70 you can take basically completely apart with no additional tools. They use a lot of plastic rivets, and then they have a tool actually inside the computer that stows in there that you can use to pop the rivets out. I'm just trying to plug the floppy drive in. Okay. So then we've got this cable. This is the hard drive power cable. It has this 4-pin on one end that goes up to the regular hard drive power connector on the other end. This is our SCSI cable. So they were nice enough to put a pull on it so you can easily detach it from the motherboard. So we'll stick this one in first. Snaps in there, and then they'll put the SCSI in. I can't really see what I'm doing, but it's really not that exciting right now anyway. Just push that in, and then the power supply slides in and then just catches. So this is a catch here that the power supply catches on. So there's no screws holding that in either. So we'll just line everything up here. Push it down in. Here it's snapping. Okay, so we'll leave the hard drive out for now, but what I will do is put the video card in, and hopefully my capacitors aren't in the wrong place for this to fit. It looks like they are not in the wrong place. So hopefully that should just stick in there, and then we'll plug this adapter in. I guess I'm still not sure which mode it's supposed to be in, so even if this is working, we may or may not get a picture. Assuming that it is working. It's promising that it made some kind of chime sound. Not quite sure what that chime means. We'll plug in. It's not the standard Macintosh II chime. Plug it on. VGA, our monitor is still powered on. You see it in the back there, kind of. Let me back this up a little bit. Okay, so then we'll just plug this in, and we'll see what happens. So it still made that interesting chime sound, but I still don't see anything on the monitor. I don't think that would be an error chime. I'm betting somebody just customized it. Hook this monitor a little bit. So let's check video cable. So probably this setting is on the stupid adapter on it, right? So I might spend another 6 hours fighting with that and see if I can get something on the monitor. Yeah, this is kind of annoying, but at least we're moving in the right direction, I think. So, yeah, pretty satisfied with how we got so far. And all we did really was replace those capacitors, so I was not expecting it to be that simple. Okay, so I tried moving the card to different slots and I tried all kinds of different configuration, and I couldn't get anything to output on the monitor, so I decided to Google it, what settings, see if I could find information on what settings that particular graphics card was supposed to be expecting. And it turns out that it says here you have to configure them to the specific display, and in order to do that you have to hold down the option key at startup and it'll auto configure or whatever. Unfortunately, my keyboard isn't here yet. I've ordered a keyboard for this, but I don't know whether it got lost in the mail or what, but it hasn't showed up yet, so we're going to have to put this on hold until the keyboard shows up. So this is going to be it for today then. Oh, I will show you the schematic. I forgot about that. So this is the startup circuit schematic. So that HC132, there's two of them. One is used in the latch for keeping the power up signal connected to the power supply. And then there's another one down here that's used in the shutdown signal. And basically what this does is the standby power goes up here and powers up this chip, and then when you push the rear panel latch down, or push the rear panel button down, it turns this transistor on, which connects that standby power to the power supply on-off. That's this line here. So this is the standby power coming in. This transistor turns on when you push the button, and then that 5 volts goes down here through that 220 ohm resistor, which is why I was using a 220 ohm resistor when I was trying to power it up with my probes, just as a safety precaution, because that's what they used. Anyway, that 5 volts goes through this transistor down to this 220 ohm, or this transistor down to this 220 ohm resistor, then back into the power supply, the power on signal, and that turns the power supply on. Once the power supply is on, then it supplies the normal 5 volt supply, comes through this diode, and then also through the 220 ohm resistor, and it keeps that latched on so that the power supply stays on, outputting. Then when you want to turn it off, you push the power button again, and then this circuit will turn on this transistor, which pulls the power supply on-off line to ground, which then turns the power supply off. And then when the power supply is off, then this 5 volts is no longer here. So once this transistor goes into limbo mode when there's no more power, then it just stays off because there's no more 5 volts here telling it to stay on. So it's not a super complicated circuit. And the issue that we had is, see these little capacitors here? There's a 47 here. That was the one I think that I was interested in. There's another one down here, so it could have been either ones. I was just testing one of the HC132s and a 47 microfarad attached to it. I'm not sure whether it was this one or this one. The numbers are different here, so this is C13, C10. Those are not the same numbers on my board. I don't know if I have a later revision or if this is from a later revision or what, but also the chip numbers are different. So this is UD13. UD13 doesn't exist in my machine. Mine's like K2 or something like that is the number, like K2 and J2 or something are the numbers for my HC132s. But I was really able to use the schematic to troubleshoot, and we found the issue in these capacitors. So I see, so there's two 10s here. We replaced two 10s, we replaced four 47s. I only see two 47s here though. Oh no, there's another one there. Not sure where the fourth one is, if it's even related. Maybe that fourth one's for something else, but anyway. So that's going to be it for this video. We're going to have to wait till I get a keyboard to see if I can configure that graphics card to output to my monitor. So I'm not quite sure which particular settings I'm supposed to be using on that adapter. But anyway, that'll be for another day. I'm pretty satisfied with how far we got. The computer now chimes, What I could do is try putting the RAM back in and just seeing if it'll work with all the RAM, because I only have one stick in there now, one SIM. This is kind of interesting though, kind of funny that we're using the iPad to basically repair its great-grandfather, or I should say, the bendy pad. Funny thing is, by the time the bendy pad gets to be this age, there'll basically be no hope of ever repairing it if it breaks, because, I mean, you can't even open this thing. You try and pull the screen off, it's going to shatter. How thin the glass they've used on here is. So, anyway, hopefully this machine will continue to live. Looking good so far. So let me just pop all the RAM back in and see if it'll still chime. Alright, so all the RAM's back in. Let's just see what it does. Ah, that's the normal sound I was expecting. So maybe that other funny sound was an error and not enough volume? I have no idea. Anyway, now it's doing the normal Macintosh IIcx chime. So that gives me even more hope that this is salvageable. Anyway, that's going to be it for today. Let's just turn it back on one more time to hear that chime. Yeah, that's definitely the normal Macintosh II chime there, so that gives me even more confidence. Okay, so that's going to be it for today. I hope you enjoyed this video, and hopefully we'll have another one soon about getting the graphics card to work, and then hopefully we can play around and see if this hard drive is going to work or not, and if we have to replace the hard drive as well. But that's it for now. Hope you enjoyed this video, and thank you for watching.